Hello friends, today we are going to repair these two quad lock dual desktop wireless chargers and unbox the warranty replacement that quad lock sent me. We're going to start off by unboxing the power adapter to get it out of the way. This is the standard single port USB-C power delivery power adapter. It supports a variable input voltage of 100 to 240 volts AC, and it comes with a 1.5 meter rubberish USB-C cable. I was disappointed to see that Quadlock's not offering a higher wattage dual USB-C port power adapter, as I'd love to have the option of plugging my watch into the same power adapter as the charger. Now we'll move on to unboxing the charger itself. Notice how it says iPhone 8 onward up to 7.5 watts in the top right corner. That is because Apple arbitrarily limits Qi Generation 1 wireless chargers to 7.5 watts, Qi Generation 2 wireless chargers to 15 watts, and their own proprietary in-house MagSafe charger to 25 watts. Here's a screenshot from Apple's website showing that Qi Generation 1 wireless chargers are limited to 7.5 watts. Here's another screenshot from Apple's website indicating that MagSafe wireless chargers can charge the iPhone at up to 25 watts. Looking at the official technical specifications for the iPhone 16 Pro and Pro Max, we can see that Qi Generation 1 wireless charging is arbitrarily limited to 7.5 watts, Qi Generation 2 limited to 15 watts, and Apple's proprietary MagSafe wireless charging can go up to 25 watts. Here's a random example of a Qi Generation 2 wireless charger that can charge an iPhone 15 Pro or 16 Pro at up to 15 watts. I was very disappointed when I realized that the quad lock chargers do not support this Qi Generation 2 technology, whereas their competitors, which cost significantly less, do. Currently, the only way to obtain the higher MagSafe wireless charging rates advertised by Apple would be to buy one of these stands that holds the official Apple MagSafe charger within them. Now that our brief intermission is over, we will resume unboxing the charger. So you can see here, similar to many other cool tech boxes, this does not have any saran wrap or tamper seals. It is designed to be reusable. First thing out of the box is this quick start guide that teaches you how to plug the device into the wall. It tells you where the light sensor is, and it teaches you what the indicator light states mean. I will demonstrate these later. Below that we have the device itself, the warranty guide, the electrical safety booklet, and this 1.5 meter USB Type A to Type C cable, which I will not be using. Now looking at the charger itself, we can see that the arm and the charging head angle is controlled solely by friction. You can also see that the arm length was specifically chosen to make sure that it can lay flat when transport. And you can see that the MagSafe charging head angle can exceed horizontal, allowing you to point your phone straight up if you wanted to do that. There's two indicator lights on the front, a USB-C plug, and a light sensor. There's also this adhesive on the bottom. Looking at the bottom of the device, we can see that output 1 and output 2 are both rated at 15 watts, but the supplied charger is only 30 watts, so this can't be possible as charging is not 100% efficient. But then if we look at the input, it says 12 volts, 3 amps DC, which would be 36 watts. Looking at the technical specifications for the 30 watt power adapter that Quadlock charged us a premium for, I'm very disappointed to see that it only supports outputting 12 volts at 2.5 amps. This is not the 3 amps necessary for the charger to charge two devices at 15 watts. Looking at the charger again, here's the cable it came with. You can see that plugs in and it sits flush. But if we instead try using this Thunderbolt cable that came with my Dell monitor, you can see it does not fit in the hole at all. It cannot be plugged in. The cable connector is too wide. You can kind of see them side by side, one on top of the other. It's just a hair too wide to fit. Using the Apple official USB-C cable, we can see that it does fit, it does plug in, but the connector does protrude a little bit. Now we'll plug the charger in and see how it works. When the charger is plugged in, both lights turn on for a couple of seconds, then fade out, indicating the device is working. My AirPod's on the base, the right light turns on and stays on. Hit on the charging head, the left light turns on and stays on. You can also see that if I cover the light sensor with my finger, the white light turns off as the charger thinks the room is dark. Now we're going to test the foreign object detection using a pop can. You can see here the left light starts flashing. I hold the pop can to the charging head. And if I hold the pop can to the base, the right light begins flashing, indicating that a foreign object is detected and that it will not initiate charging. And now we'll test it using the quad lock phone ring. As you can see here, flashing light, foreign object is detected, charging will not initiate. This is the charger the quad lock warranty ended up replacing. As you can see on the base here, there's 4 screws, 1 in each corner, and an additional screw in the center. While I work on peeling back the adhesive and the sticker and removing these screws, I'll tell you a little bit about the history of this charger. So this is actually my second warranty replacement from quad lock. The original charger that I purchased had a defective light sensor. The sensor was not sensitive enough and would always assume that the room was dark. So even if the room lights were on, the lights on the front of the device were not staying on. So they replaced it with this one. This one worked for about 11 months until recently it began to intermittently stop and start charging. Here you can see me try to pry the bottom cover off because I was originally unaware that there was a screw in the middle of the base. I thought it may have just been glued down. Now once we get this last screw out, we can remove the bottom cover. Notice that on the inside face of the bottom cover, it is directional. All of the screws are symmetric. The cross-hatching reinforcement on the bottom is not. As you can see here, there are these 4 wires, 2 sets of 2. These go to the wireless charging coils. There's the USB-C connector, and there's the light sensor. This is a light-dependent resistor. The leads for this light-dependent resistor are not actually wires, they are just the normal light-dependent resistor leads covered in some sort of heat shrink tubing. It's not held in place with any type of glue or any type of attachment. Now we're going to remove the 4 screws that hold the circuit board down. Conveniently, these are the same screwdriver bit as the screws that were holding the cover down, but they are not the same length. The screws now removed, we'll try and pry up on the circuit board by pulling on this antenna wire. I was originally expecting this board to be held down with some sort of double-sided thermally conductive tape or thermal paste, as the base is aluminum, will be a great conductor of heat, but it turns out that there is nothing that attaches this PCB to the charger. As you can see, the bottom of the PCB is blank. One of the reasons I originally purchased this charger is because I really liked how it was isolating the charging circuitry where the phone was, so that it would not be heating up the phone. For anyone interested, here's a still photo of the circuit board. It's a single-sided PCB. Near the bottom you can see the 2 white indicator LEDs that are on the front of the charger, and the top left corner is the USB-C port. After looking at the charging circuit board for a while, I noticed something really interesting. Plug it in. If I press down right there with my thumb, the charger begins to work. When I let go, the charger stops working. problem appears to be that the solder connection between the USB-C connector and the circuit board has broken. If I hold the circuit board next to my ear while pressing down on that connector, you can hear what sounds like a little arc. If we try this using the official Apple USB-C cable, it does not appear to work. Seems to work less reliably than the quad lock provided USB-C cable. I'm not exactly sure why. But most importantly, we now know the problem is with the way that this connector is soldered. Solder connection is poor. What needs to be done is this connector, because it's a surface mount connector, it needs to be placed in a reflow oven, either with new solder paste or with flux, and reflow soldered back onto the board. Since I don't own the equipment necessary to reflow the circuit board, I reached out to Quadlock to see if they would sell me an entirely new PCB I could solder in, and they promptly said no. When that didn't work, I found this random guy on Kijiji, which is like the Canadian Craigslist, who offered to reflow the PCB for just 15 Canadian dollars. It's like 11 USD. So I dropped this charger off to Steve without any of these screws or the bottom cover installed because I both was scared of him keeping it and because I wanted to show you guys what the final product looked like. As you can see here, one of these wires fortunately came loose while I was putting the board back in because he didn't do a great job soldering it. It's a little bit difficult to solder because the wire is springy. It needs to be held with tweezers while soldering. You can see this other wire he soldered, he burnt. And the wire is also incredibly close to that pad on the PCB, but it's not touching, so it is okay. We're going to first install the 4 screws that hold the circuit board down, and then we're going to solder that one wire back on together. Due to the wire's natural springiness at the angle it's at, soldering this down is a little bit complicated as you need to hold both the charger, this pair of tweezers, and the soldering iron all at the same time. So what I'm doing here is I'm heating up the solder joint, and I'm going to hold it down with the tweezers while it cools. This is best done with this soldering iron at the lowest possible temperature, which is about 200 degrees for me. See here, it doesn't look great, but it is acceptable to me. Now we're going to clean the tip of our soldering iron with a bit of brass wool by dabbing the tip into the brass wool before we allow the soldering iron to cool down. This just removes any solder that's stuck to the tip. Now we're going to tuck the antenna wires to the side so the bottom cover will fit, and we're going to adjust the angle of our light dependent resistor so that it correctly faces the window on the back of the device. I played with this angle quite a bit and tried moving it around various times in various orientations, and I could never get it to be as sensitive as the new charger they sent me to replace this one. I'm not sure if it's just a skill issue. Now we're going to put our bottom cover back on. Remember, this bottom cover is directional. On the inside face of the bottom cover, there's a smooth side that goes towards the back of the device. It's to make room for these screws for the hinge mechanism. device was not sitting flat and had a bit of a rocking motion, so I ended up tearing off the rest of the adhesive on the bottom to allow it to sit flat on the table. Now we're going to quickly test it. As you can see here with the AirPods on, both lights turn on. The right light stays on, but it stays on rather dim, likely because that light dependent resistor is not correctly aligned with the window. Overall, I'm happy that this now works and have deemed this repair successful and will be using this charger. Thank you for watching. Please leave any questions, comments, or concerns you have in the comment section down below. I currently attempt to read every comment that is left on every one of my videos.